Hi there, Mr. Patrick here, and we want to teach you today a little bit about square roots. So in order to understand what a square root is, we need to understand what a square is. Well, I think you know what a square, the shape looks like. What I'm talking about is a square, the operation, or a special case of an exponent. So what we're doing here is, here's a square, and we want to find the area of the square. Well, there's a grid shown on it, so you could just count the number of squares that are inside, 1, 2, 3, 4, or you could multiply length times height. But in this case, a square is going to be the same. The lengths are always going to be the same, the length and the height. So we could say 2 times 2 equals 4. Another way to say that is 2 squared equals 4. Because the lengths, the bases, and the heights are always going to be the same, we can write this little 2 here to show that we're multiplying the same number twice. This is an exponent, and it's a special exponent we call a square. Again, another example, this would be 3 times 3, or we could say 3 squared, which is going to be equal to 9. One more just short example here, 4 times 4, so this is 4 squared. Again, that's going to be 4 times 4 equals 16. Now, of course, these should have units. If I said units, the units would be units squared. We say squared, but even though it's a little 2, to represent that this 2 is the area of a square. Now these little numbers up here are actually are part of a math operation called exponents. And you can have other numbers other than just 2. If I had 5 to the power of 3, which is an exponent, you would multiply 5 3 times by itself. 5 times 5 is 25. 25 times 5 is 125. You could do another one, 2 to the power of 4, 2 times 2 times 2 times 2. That is going to be 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that's how exponents work, and they say 2 to the power of 4, or 5 to the power of 3. But we're not too interested in exponents, because we are interested more so in the special case of squares. Okay, so let's just work with squares here. Before I do, let me introduce the idea that in math, if I had multiplication, and I said, what's the opposite of multiplication? You'd probably say the opposite is divide. So an example, if I said 3 times 5, it's 15. If I wanted to undo that multiply by 5, I could divide by 5, and I would equal 3. Basically, I'm starting off with the same number. I'm undoing what I did with multiplication. They're opposites. I can do the same thing with addition. The opposite of addition is subtraction. So what I could do here is I could say 5 plus 3 is 8. If I want to undo that plus, I could minus by the same number, 3, and I'm going to end up with 8 minus 3 is 5. I'm kind of undoing that operation, or in other words, it's an opposite operation. So with squares, the same thing holds true. If I have a square, 3 times 3, that's going to equal 9. What a square root does is it is the opposite operation of this. And well, the symbol is a really cool symbol. It looks like this. Little cool check mark. Square root of 9. It undoes this operation, and it asks, what two numbers multiply together to get 9? And it would be, the answer would be 3. So a square root undoes this square. So in other words, a square, let's say 3 squared, is opposite, this symbol here, this square is opposite to a square root sign. These two operations are opposite to each other, or they undo each other. Okay, give you a quick example, a couple of examples, just to show you what it does, what it looks like. So if I had square root of 16, what two numbers multiply together to get 16? If you look on the multiplication chart, you'll notice that 4 times 4 equals 16. So we just write 4. We don't write 4 times 4, we just write 4. Square root of 25, two numbers multiply together to get 5. Oh, 25, it's 5. Give you one more. What two numbers multiply together to get 81? That would be 9. So that would be the square root of 81 would be 9. Thanks for your attention.